So now that I gave you a quick overview of the concept of processing order and results order, let's do a deeper dive into the order of results and how you can order results. And we'll start by talking about what does this even mean. So we talked before about the order in which things are processed was non-deterministic and you had no control over that. The order of results, however, can have some control and you can influence how those things are done. So it can be made entirely deterministic how the results are presented to you. And what you can control is you can determine if the results should be presented in so-called encounter order. And you can read more about encounter order here. I will explain the concept of encounter order. It's actually a very simple concept. Encounter order is simply the order in which the stream source, which of course is where everything originates from, makes the elements available. And so let's assume for the sake of argument that we've got an array list or a list of some kind. And so you've got, array list location 0, array list location 1, array list location 2, array list location 3, et cetera, et cetera, et cetera. You can ensure that no matter how things are processed, once we put the work into the underlying common fork join pool, that when the results come back, the results for item 1 will be, or item 0 will be first, followed by item 1, followed by item 2, followed by item 3. So you can control the order to maintain so-called encounter order, or EO. So under what circumstances is EO, or encounter order, maintained? So the encounter order will be maintained if the source is ordered and if the aggregate operations used in processing are obliged to maintain the encounter order. And I'll explain and give you some examples of that in a second. So if you recall when we talked about sequential streams and the implementations of how that worked under the hood, I mentioned how there were these different characteristics that sources could have, right? So for example, an array list is ordered, whereas a hash map is not considered ordered because we don't really know or care how things are laid out in a hash map. But in an array list, there's location 0, there's location 1, there's location 2, and that goes in a certain order. Remember also that ordering is not the same as sorted. So sorted means the items are actually sorted, they're ascending or descending. Ordered just means that they have an ordering that's implicit in the way that the data structure or the collection is defined. So what's interesting about this is encounter order can be maintained irrespective of whether a stream is parallel or sequential. So if you have a parallel stream and you have sources and aggregate operations that maintain encounter order, the results have to come back in encounter order, even though the processing took place in randomly chaotic orders that you don't understand and can't control. Performance may differ, however, and that's the key point I want to make to you. So if there's some reason that you don't care about the order in which the results show up, you may be able to get faster performance because there's no need to rearrange things at the end. There's no need for the streams framework to rearrange stuff. So keep that in mind as we talk through the examples. So that was just a quick overview of the concept of results ordering and how you can influence it by choosing the appropriate sources of data and the appropriate aggregate operations. We'll now take a look at some examples that will make it more clear.